Hello friends, myself Sundar Kumar. I am taking electrical machine design for the electrical engineering students of second semester. Now, in the previous lectures, we are discussing about the various things related to the electrical machine design regarding the DC machines, regarding the parameters which are associated with the electrical machine. Now we are discuss about the performance prediction of the electrical machine while we have just designed the DC machine. The performance based on the design data of the stator and rotor of DC machine. Performance of the machine has to be evaluated by the different parameters, and these parameters will be associated with the calculations, and some parameters are focused on the geometrical columns which will be designed, and some handbooks will be given which have the some values are associated. So over here we are just looking on these things that the iron, there is one parameter which is associated over here is the iron losses, load of current losses, load of power factor, and the leakage reactance and etc. Based on the values of these parameters, design values of stator and rotor can be justified. Iron losses are occurring in all the iron parts due to the varying magnetic field of the machine. Iron loss has two components, hysteresis and additive losses occurring in the iron parts, depend upon the frequency of the applied voltage. The frequency of the induced voltage in rotor is equal to the slip frequency, which is very low, and hence the iron losses occurring in the rotor is negligibly small. Hence, the iron losses occurring in the induction motor is mainly due to the losses in the stator lobe. Iron losses occurring in stator can be computed by the different parameters like that. First, define gap expansion factor and give the expression for it. The ratio of reluctance of flux path when armature with slot to reluctance of polar flux path when armature without slot. So KCS equal to YS upon YS minus KCS WL is will be more than one slot. KCD it will be L, it will be equal to L upon L minus ACD, and the WD is more than 1 times. So what is the advantage of large number of poles? Weight of iron parts decreases, weight of copper part decreases, length of commutator reduces, overall length of machine reduces, distortion of field form becomes less at full load condition. These are the questions which will be associated with the DC machine, and these all we will discuss, and what are the exactly the solution of these questions we are just discussing over here. Why the interpole is used in an DC machine? It will reduce the armature reaction and helpful to improve the compression. Why the brush is made of carbon? To reduce sparking between brushes and commutator, we are using the carbon. To conduct electric current, to avoid wear and tear due to rubbing of the brushes due to the movement of the commutator. Define leakage coefficient and give the equation for it. The ratio of total flux per pole to the flux to the useful flux per pole is called the leakage coefficient or leakage factor, and this will be equal to the phi p upon phi, where upon phi equal to phi into p, where phi it will be 1.08 to 1.25 times. Define iron stacking factor. It is defined as the ratio of net length of armature to the gross length of the armature, and the value of this one is 0.9 to 0.93. What is mean by peripheral speed of armature? The distance traveled by the armature per unit time is called as peripheral speed. So over here the N is speed in RPS, D is the diameter of the armature in meter. So V equal to summation of the D times N, and the unit of this one is the meter per second. Define armature reaction. The flux produced due to the current flow to the armature conductors which opposes the mean flux. This phenomena is known as the armature reaction. What are the effects of armature reaction? It reduces reduction in the EMF, increases in iron losses, sparking and ring fire increases within the machine, delayed commutation. What does staggering of brushes mean? Brushes are provided in different planes instead of same plane at the surface of commutator to provide the formation of ridges. This is called the staggering. Mention the different modes of operation of a DC machine. As we in the previous lecture we are discussing about that there is a different types of operations are there. So first operation is the generator mode. In this mode the machine is driven by a prime mover with mechanical power converted into electrical power. In the motor mode the machine derives a mechanical load with the electrical power supplied converted into mechanical power. Brake mode, the machine works as a generator and the electrical power W is either pumped back to the supply as in a generative braking. State use of a yoke in a DC machine. The yoke serves as a path for flux in DC machine and it also serves as an enclosure for the machine. What purpose is served by the pole machine in a DC machine? The poles who serve the following purposes. They spread out the flux in the air gap. Since they are of larger cross section, the reluctance of the magnetic flux is reduced. They support the field coils too. Mention the factors that affect the size of rotating machine. The factors that affect the size of rotating machines are speed and output coefficient. What is known as output equation? The output of a machine can be expressed in terms of its mean dimension, specific magnetic and electric loading, and their speed. The equation describing this relationship is known as the output equation. Derive the output equation of a DC machine. Power developed by armature in kilowatt is called the power, is the output equation. Then power is equal to generated EMF into armature current into 10 power minus. We have to indicate in the kilowatt. So this will be the relation which we are getting over the power output. How is specific magnetic loading determined? The specific magnetic loading is determined by maximum flux density in iron parts of the machine with magnetizing current and core losses. Calculate the output coefficient of a DC machine generated from a given data DC 0.89 Weber per meter square, AC is 2200 ampere conductor per meter, Xi is 0.66. So output coefficient is C not equal to 5 square. Xi Bg AC into conformal just by put up the values we are getting the 185.5 kilowatt per meter cube RPS. What is the range of specific magnetic loading in DC? The usual range of specific magnetic loading in a DC machine is 0.4 to 0.8 Weber per meter square. What are the factors to be considered for the selection of motor or selection of number of poles in DC machine? There are various factors which are associated for selection of number of poles in DC machines are frequency, weight of iron parts, weight of copper, length of commutator, lab or charge, labor charges, class of work and distortion of the field element. What are the quantities that are affected by number of poles? Weight of iron and copper, length of commutator and dimension of brushes are the quantities which are affected by the number of poles. List the advantages. The larger number of poles resulted in increasing the following parameters: frequency of flux reversal, labor charges increases, possibility of clash over between brush arms. Mentioning guiding factors for the selection of number of poles, the frequency should lie between 25 to 50 Hz. The value of current per parallel path is limited to 200 ampere. Thus, the current per brush arm should not be more than 400 ampere. The armature NMR should not be too large. The NMR per pole should be in the range of 5000 to 12500 ampere turn. Choose the largest value of poles. It satisfies the above three conditions. What are the losses at the commutator surface? The losses at the commutator surfaces are the brush contact losses and brush friction losses. Write down the expression for brush friction losses. The brush friction loss is given by PBF equal to mu PB, AB and BC, where mu is the coefficient of friction, AB is the brush contact pressure, AB is the total contact area of all brushes, BC is the peripheral speed of the commutator. What are the advantages of carbon brushes? They lubricate and polish the sparking occurs, they damage the commutator less than with the copper brushes. They provide good commutation to the machine. What is the height occupied by a series field coil in a field pole? In a field pole of compound machine, approximately 80% of the height is occupied by shunt field coil and 20% by the series field coil. How the ampere turns of the series field coil is estimated. In compound machines, the ampere turns to be developed by the series field coil are estimated to be 15 to 25% of the full load armature element. In series machines, the ampere turns to be developed by the series field coil are estimated as 1.15 to 1.25 times of full load armature element. And some the factors to be considered for design of shunt field coil. MMF per pole and the flux density, loss dissipated from the surface of field coil, resistance of the field coil, and loss with the current density in the field conductor. State the use of interpoles. The interpoles are used in DC machines to neutralize the cross-magnetizing armature MMF at the interpolar axis and to neutralize the reactance voltage in the coil undergoing to commutation. How is the length of commutator designed? The length of the commutator is designed based upon the space required by the precision upon the surface required to dissipate the heat generated by the commutator losses. Length of the commutator is where N is the number of brushes per spindle, W is the width of the each brush, C is the clearance between the brushes, C1 is the clearance for allowed for staggering the brushes, C2 is the clearance for along the end for end plate. Explain how depth of armature core for a DC machine is determined. This will be the formula which we have calculated on the previous lecture. Now this is the only the explanation. There will be some problems which will be associated with the DC machine and you must be tried to find out the solution of them just to make a command on the DC machine. So this will be the end of the DC machines lectures and in the next lecture we will discuss all the new machines with a new concept and with a new dimension. Because up to this part we are just discussing about the DC machines. Now we will discuss about the AC machines in the later on lecture. Now thank you for attending the lecture. Thanks.